Here we're going to look at learning how to generate the equation of a trig function based on the graph of the function. So maybe this will help a little bit. All right, let's look at this one here. By the way, these are different than the assignment I handed out. Let's look at this one. The first thing you need to try to identify is whether it's a sine, cosine, tangent, cotangent, secant, or cosecant. And when I look at this graph, in the back of my mind, I'm thinking, well, I know that if I just have y equals sine of x, my graph will start at the origin and complete its first period like this. And that's what we have for this problem. So we're definitely looking at a sine graph. The next thing we have to do is identify all the rest of the stuff. You know, the overall equation is a sine of bx minus c plus d, where you have a is the amplitude, b is your period, c and d represent any kind of shifts. And I'm looking at this graph. This graph is not shifted up, nor is it shifted left or right, so I'm automatically going to ignore the c and the d, which gets me down to some equation that's going to look like a times the sine of bx. And if you remember, a is the amplitude, and I'm looking at this graph, and I can see that from my midline up to a peak or a trough, if you want to go up or down, that is a distance of 4. So I automatically can tell that a is equal to 4. Then the last thing is to get my b, and that's going to be the tricky part on these graphs. B, if you remember, is what gives you the period. We know that the period is 2 pi divided by whatever b is. So the way I'm going to get b is I'm going to take that formula, and I can look at this graph, and I can see that one period begins and ends at 0 and pi. So my period is pi. And since I know what the period is, I can set 2 pi over b equal to 1 pi. And then we simply solve that equation for b. I am dividing by b, so I'll undo that by multiplying. That will give me 2 pi is equal to pi times b. And remember, we are trying to get b, so my next step, I'm going to divide by pi to undo this part. So divide by pi. Those cancel, these cancel, and we simply get 2 to be b. And now that I know what a and b are, I can go on and finish this problem and say that the equation of this graph is y is equal to a, my amplitude was 4, sine, and based off the period of pi, I was able to determine that the coefficient of x is 2. So 4 sine 2x would be the equation of this graph. So we're basically doing what we were doing earlier, just in reverse. Let's try a different one. Let's try this one. Let's see. I recognize this as either sine or cosine. And in the back of my mind, I'm thinking, I know that sine starts at the origin and goes up. I know that cosine starts at its amplitude and completes its first period like that. So based on those two, this thing is not starting at the origin, so I'm going to rule out sine. This thing starts away from the origin, which means it's going to be cosine, except this starts down here at -3, starts below the x-axis. So I'm thinking this graph is going to be y equals some negative cosine. And I'll go ahead and throw in the rest. It's a cosine of b, and then you have shifts of c and d. But again, just like the last problem, this thing is centered on the x-axis. It's not shifting up or down, so that rules out a d. And I'm not shifting this thing left or right either, so I'm going to get rid of c. There's no shift on this graph, which means I'm now, just like the last problem, down to simply finding the amplitude, and I will use the period to find b. Amplitude is always the easy one. From midline to peak is a distance of 3, so my a is 3. And I will use the period to get my b, just like I did before. I start down here and I complete my first period from 0 to 2 pi. So I can tell that my period is 2 pi. And remember, the period is, the formula for period is 2 pi over b. So my period, 2 pi over b, has to equal 2 pi. And then we'll solve that equation. Multiply both sides by b. multiplied by b, those cancel. 2 pi equals 2 pi b, and then we will divide by 2 pi. Divide by 2 pi. And this is kind of a nice one because everything cancels. Everything cancels, and you just get 1 to equal b. Everything cancels. So now that I know what b and a is, I can now go on and complete this equation. And I know the equation is y equals, it's negative because I start below the x-axis, negative 3 cosine of, and b is 1. So you could just write x, 1x. If you want to put a 1 there, that's perfectly fine. Neither one is incorrect. So there's our equation for this graph. Again, identify the amplitude, the period, and the trig function, and we work backwards from that information. I think I have 2 more for this video. 2 more. Okay, looking at this one, now we're getting a little bit trickier. This is not a sine or cosine. This looks like a secant or a cosecant. And with secant and cosecant, remember you graph the humps of sine or cosine. Notice this thing is shifted up 1. And what I'm going to do is pause. Okay, so when I'm trying to determine whether this is a secant or a cosecant, remember as I was saying a second ago, we graph the humps of sine. So what I'm going to do is figure out whether this is humping, there we go. I can't believe I just said that on a recording. Whether we're going to be graphing the humps of sine or cosine. I know that my base graph is going to have to come up right there and come down. It's going to have to bottom out right here because we're graphing the humps of a sine or a cosine. So that's telling me that my original graph is going to have zeros. Remember, you graph asymptotes where the original graph hits the midline or the x-axis. And I'm going to graph the rest of my base graph. It's going to come up, come down, come up. And the reason I'm graphing this is if I see this graph, I can come up with the equation of this graph like I did the other sines and cosines. And then from there I can figure out whether this is secant or cosecant. So this graph is starting at the midline. I shifted it up 1, so there is a shift to deal with, but we're starting at the midline in essentially what the origin would be, which tells me that this is going to be the red graph is the graph of sine x, which starts in the middle at the origin and completes the period like this. So if we're dealing with a sine, so for the red graph, I know this is going to be y is equal to some crazy amplitude times the sine of, there's some period change, so bx. There is no shift left or right, so I'm not going to worry about the c this time, but I do shift up 1. So I'm going to go ahead and say plus 1 because my graph is shifted up 1. That was not supposed to be dotted. So the plus 1 is because my graph is shifted up 1. I'm going to go ahead and put that at the beginning. Now I've got to find the amplitude and the period of that red sine graph. Amplitude is pretty easy. From midline to the top, that is a distance of 2. So my amplitude is 2. And then my period, if we look at one period, I start and finish my first period at 4 pi. Start at 0 and end at 4 pi. So my period, which is found by 2 pi over b, needs to equal 4 pi. Because that's what the period is. From here to there is my period. And then we solve that equation for b. So I'm going to multiply both sides by b to get rid of that fraction. Over here they're going to cancel, and we'll have 2 pi is equal to 4 pi b. Then we will divide by the 4 pi to solve for the b. Then we start canceling. 4 pi's cancel. Will leave me with just the b over here. Here the pi's cancel, and 2 over 4 is 1 over 2. So there's my b. So now I have a, b, and I knew I shifted up 1. So I know that the red graph is going to be y is equal to my amplitude, which is 2, times the sine of b, which is 1/2 x, and I shifted up 1. So there's the equation of the red graph, which which is my base graph. But the black graph is what we're trying to find the equation of. So my black graph, we graphed the humps of sine, which means my black graph is going to be a cosecant graph, and everything else is going to be the same. Amplitude is 2, except now it's cosecant. The period was 4 pi, so it's still 1/2 x, and we're still shifting up 1. So there's the equation of the cosecant graph. So sketch in either the sine or the cosine, and then find the equation of that one, just like I did those first two examples, and then you simply change it to cosecant or secant, whichever applies. In this case, it's cosecant. Okay, last one, and this one is a either a tangent or a cotangent. This is kind of a tricky one. I see the asymptotes. Let's see, it's flipping up. Let's see. This is either a cotangent or a cotangent. And if you remember with tangent and cotangent, the vertical asymptotes occur where your base graph, which is either sine or cosine, hits the x-axis. Now this one is centered on the x-axis, so there's no shift up or down. And just like that other graph with the cosecant, I'm going to start by sketching my base graph, whether it's sine or cosine. And this one's going to have a couple of interesting things. This graph right here actually has a few different answers that we could go with. But I'm going to try to choose what I think is the easiest. This looks like it's going to be a base of sine. Remember, vertical asymptotes occur where your sine or cosine graph hits the x-axis. And based on where the roots are, where the vertical asymptotes are, my base graph is going to start going up, and then it's going to max out, and then it's going to come down and hit my x-axis like that. Anywhere your base graph, which in this case looks like to be, it's a sine, hits the x-axis, you have the vertical asymptotes for your tangent or cotangent. So I'm looking at the red graph now. Looking at the red graph, which appears to be a sine graph. So we have some amplitude, sine, and there is no shift left or right or up or down. So I'm simply going to do a sine bx. I don't have to worry about any shifts. And this is part of the, this is where some math teachers are going to be mad at me, because based on this graph, we don't have enough information to determine the amplitude. I could have drawn this sine graph as tall or as short as I wanted, as long as I'm hitting my x-intercepts at the right spot. So for this problem, we are going to disregard A. We're going to disregard the amplitude because I didn't give you enough disregard. Am I spelling that right? That's crap handwriting. We're going to disregard amplitude because amplitude with a tangent or a cotangent graph is a little bit trickier than it is with a sine, cosine, secant, or cosecant. So we're going to disregard amplitude, and now I'm only down to finding the period, and I can see that this sine graph begins at 0 and ends at 8 pi. So our period of the red graph, and remember period is 2 pi over b, needs to equal 8 pi. And we'll solve that equation the exact same way I solved all the rest. I'm going to multiply by b first. Those will cancel, giving me 2 pi equals 8 pi b. And then we will divide by 8 pi to solve for the b. Divide by 8 pi. And let's see, pi's cancel. 2 over 8 is 1 over 4. Over here, the 8 pi's cancel, leave me with the b. So 1/4 equals b, which means my red graph is going to be y equals the sine of 1/4 x. Now the thing is, that's my red graph. Now to get the black graph, we have to decide is this tangent or cotangent or what's happening. Now the shape of it looks like a tangent graph, because tangent, if you remember, I told you it starts low and goes up high. But the problem is my sine graph is determining the asymptotes, which means sine is what's going to be on the bottom of the black graph. So my black graph is going to be cosine of something over sine of something, and cosine over sine, since sine is on the bottom to give me my asymptotes, cosine over sine is actually a cotangent graph. And if you remember, your cotangent graph does have an asymptote on the y-axis. So rather than use tangent, which is how this thing looks because it starts low and ends high, I'm actually going to go cotangent on this one. Whoa, black. There we go. I'm actually going to say this is a cotangent graph of 1/4 x. And then the last thing we have to take care of is, if you remember cotangent, that's supposed to be a y. If you remember your cotangent graph, I told you that you do have your vertical asymptotes, and cotangent starts up high and comes down like this. Well, this problem is not in that direction. It's starting low and going up high. So all we've done is we've flipped that thing upside down, and to flip a graph upside down, you make it negative. So I'm going to say that my flat graph is the negative cotangent of 1/4 x, rather than having to deal with tangent. And that's one of the things that makes tangent and cotangent a lot trickier than the rest. I think the first three were a little bit more straightforward. This one is kind of a touchy-feely problem, and I'm guessing if the Math League of America or some college professor or some strange teacher out there was watching this, they'd be mad at me right now. But, you know, this is how I'm going to do it, and they can be mad at me, and it's not going to bother me too much.